Alright, so here's a quick video on how to get into TAMU faster and use GPUs on that system. So first of all, I'm just starting here at Google. I'm going to log into the portal. I have already logged into Access first though, so I would go to accessci.org and log in first. That way you'll just be forwarded. You can just try to go directly to the portal, but you'll have to complete the login process if you do that. But if you do go to the portal, then you'll see this message, right? So once you get here, after you go through the full login process and sign in, then you'll be able to access this interactive session box right here, My Interactive Sessions, and you can use that to start up a Jupyter notebook or Jupyter Lab. Jupyter Lab has limited functionality on the system, so don't use that particular link. Instead, start up a Jupyter notebook. Now when you click this, the option that you'll want to select here from the top is Containers Singularity, so that we can use our stack. You'll want to copy and paste this information, which I provide on the Discord and also on the course website, which is the path to the Singularity image file that we're using. This is the same stack that we're running on all of our clusters here on campus, but this allows us to run this also on their systems. Usually for starting jobs, you want to then pay attention to a few items in this field. Probably safe to put it on about 4 cores and 32 gigs of RAM for most of the work in this course. I'll give you updates or tell you if we need to change that in some way. The more important thing may be the number of hours. You'd have to kind of anticipate how long you're going to be working on this particular system. So here I've just asked for 1 hour, but you may want to ask for more if you're trying to program and work on things. The important thing there is just to, you can select up to 168 and you can keep that the entire time, but we want to make use out of these. So while you're not using the system, right, it's good to maybe set it to a reasonable number of hours. We probably won't work any more than maybe 10 hours at a time. So I would recommend not going past that point, just so you can release the GPU for someone else to use at that point. For the node type, you have a lot of options here, right? Don't pick a non-GPU because you won't get any acceleration if you do that. T4s are nice, and they're the smallest card on the system, but they're 24 gigs each in memory, so they'll probably suffice for most of our projects, so I'd recommend picking that one. There are larger slices that you can get by picking some of these others. The A30s and the A40s are about 50 gigs. The A10 is also another 24 gig card, and the A100s are 40 gig cards. So these basically 30, 40, and 100 will give you a lot of extra memory, maybe potentially an extra speed boost as well. Feel free to try them out if you'd like, but I would recommend sticking with T4 most of the time. It'll probably get the job done on most of the projects, and that's what I'm anticipating people will use unless I tell you otherwise. For a number of GPUs, we're just going to be using one when you're selecting an interactive session, so don't pick more than one. You won't be able to adequately take advantage of more than one GPU on an interactive session inside of Singularity currently. I may change that in the future and find updates on how to change it, but most of the time if we need to do any multi-GPU training, we'll be using scripting instead. So this is how you would set things up, and once you have it ready, you'll be able to launch that and it'll go into the queue. Your session will start up. Now it may take a moment for this to happen. It may be fast. Oftentimes it is very fast to get access to the T4s, which is why I like this system. It's a nice fast GPU, and you can already see that it's already popped up and is now available, which will allow me to connect to my Jupyter session. And once you click that, you'll be directed directly to the notebook. So remember, it was a Jupyter notebook session. It'll look a little strange at first. So this is the older Jupyter notebook setup. If you're comfortable with that or want to use that, feel free to do so. They are really just, basically the same thing. This is just an older interface for Jupyter. But if you go up to the top and you change this tree setting to lab, then you'll get to the Jupyter Lab that we're used to on most of the systems. So this will allow you to use it in the exact same way that we've been using it on our systems here. Now, one thing I want to keep in mind is that now if you want to check, you should good idea to verify that you have access to the GPU by going to a terminal and typing the NVIDIA SMI command. And when you use that command, you should see this sort of boilerplate pop up. If you don't find any GPU, then you've probably selected a CPU only. So here you have, sorry, these are 16 gig cards. I guess my notes are a little wrong here. So these are 16 gig Tesla T4 GPU that you can use for running jobs. I already have a script that we use like on my last lab here, which is the CIFAR residual.py. And so if I want to, right, I can run that directly here. And what that's going to allow me to do is run this job basically non-interactively, but it's inside of my terminal. Of course, I could have been working on things in notebooks. They will also have access to the GPU. There are only so many jobs you can run at a time, and you'll run out of memory on the GPU, so just keep in mind that you may have to close and stop other running notebooks using this tab if they're currently running and taking up any kind of memory on the GPU. You can always monitor how the GPU is doing, right, to be able to do that. So here, I get the error where I've forgotten to remove my log files, so let me do that real quick, right? So this residual directory needs to be removed. All right, now we can run that again. So that's the thing I pointed out in class, and if you don't clear your log directories, it'll end up getting confused a little bit, which is normal. But after that, we should be able to see everything take off, and we'll see that our runs are considerably faster, right? So you're talking about a few seconds per epoch as opposed to the minutes per epoch that we were waiting before. So this means jobs that used to take us 5 or 6 hours are actually done in about 5 or 6 minutes. And so this allows us to be able to run some much more significant workloads for this semester. So I will just point out that this is how you'd work on things at the terminal. You can always, of course, start up notebooks and start hacking away and building code just like we normally have. The other detail that you want to be aware of is the location that you're being granted right here, because if you do need to access the system via terminal directly, then you can go back over to the portal, pick on clusters, and then the shell access button. So again, that's just clusters and then faster shell access. It'll open up this tab and you'll be able to see a shell. And what you're currently working on is not in your home directory. So notice here I'm typing ls, I'm in my home directory, and there's nothing there because I'm not actually running any of these files in my home directory. There is this other location that has a lot more space in it that you really want to use anyway, called Scratch. So that's where we're actually running everything at the moment. You can always get to your Scratch directory by saying to use the Scratch variable. So if I cd $Scratch, then I will change into that directory, and now I'm in my Scratch directory, and that's where all of my files are that I was seeing there in the notebook. So anything that you upload or put here, it goes in a Scratch directory. Scratch is sometimes cleaned out from time to time, so this isn't really a permanent location. I would say once you're done finishing up whatever your assignment is and whatever you're doing, you may want to copy that information back over to your home directory. You can always use the $home variable to put things in your home directory, or of course, ~dot also works for that. But you're copying that back over to home. To get back to your home directory, you just use cd by itself. Now I'm back in the home directory, and once I'm in my home directory, then I can look and see that I've got that file here. Home will not be cleared out. It's just the fact that if you use the show quota command, you can see how much space you have. Home only has 10 gigabytes worth of space. Scratch has up to 1 terabyte. So you can do lots of work over here, and large data sets and other things can be downloaded, which we'll use. So you want to use the system, and then when you have something that you want to keep, kind of make sure that it doesn't get deleted, then you want to move that over to your home directory for kind of permanent storage. You can also then, of course, you can always zip things up, just like we've been doing. So you are running the same stack that we've been running as before. So whenever you're done, you can zip up your OLA here, right? If this was the only file I needed, maybe I'll zip this up. Maybe I'll zip up that this augmentation Python notebook in it, right? So you get everything in your zip file, and when that's created, you can download it the same way that you've been doing so far, right? Just go ahead and download, and you can upload that to the assignment system. But if you do want to keep things permanently stored on Faster, then I would recommend moving things over to the home directory. This stuff might be cleared out from time to time, so you should think about it as a temporary space where you do your work, you have the space you need to do it, but then your final results and notebooks will go back into your home directory, because data sets and things like that get quite large. If I sort of look at the size of information here, right, that's 341 megabytes just in the CIFAR 10 data set. So as we get more data sets and train with other larger models, we're going to take up a lot of space. That's all temporary, because once we're done, we just collect the results, make our plots, and run our statistics, and that's what you end up turning in. So code, stats, and things like that. And let's see. So I think that's everything really as a main intro to Faster. If you need to change the settings, we'll discuss that in class. When you get done using your session, I would say if you know you're done, rather than letting the time run out, you've got a couple of options. You can go up to File and hit Shut Down, and that will shut down the session. Once you do that, it will shut down, and you'll have to go and submit a new job, get a new interactive session. Alternatively, if you pick Shut Down, you can also then just close it and go back to the portal and use the delete button, and it will say, are you sure? And you just say this, and that will clear it out, and then you'll have no active sessions. And so at that point, we've also closed the job down. You can also check things that are running in the queue anytime. So I'm using SQ here just to see what I've run. There are lots of jobs usually because lots of people are using this machine. I'm looking for my username. I don't see any jobs for me currently, right? But if I end up using starting up a job again, just so I can see, we'll see what else we can get here. I'll launch another session, retains those last settings, which can make it nice, but the job will start up. Probably will end up starting up pretty quickly. We can also use scripting and other things as well, so I'll take a quick look at that while I'm making this video. So let's see. Yeah, so this is currently waiting. I'll just wait for that to start, but I can look for it in the queue, and I can see that the job's pending, so we're waiting on a GPU right now due to priority. So somebody else is probably grabbing the GPUs right now. We'll have to wait for just a minute. It may not take too long. Yeah, there it goes. It's already actually running now. I can go back to this, and it will tell me that it started here in just a moment. And so at that point, then we could get back into the interactive session. So otherwise, though, you can run things non-interactively. So if you wanted to submit jobs, you would do that from here. So if I'm in the home directory, I don't really want to run from there. Again, go to Scratch. This is where I would want to submit things. I would have a shell script that would be my wrapper. I do want to make sure that that's set up properly. So I'll use CIFAR10 residual shell. I do need to update it a little bit because I've moved my stack around a little. And I'll set it to the same settings that you all are using, just so we've got it. So the key thing that I would recommend here is that you utilize some settings, and I might have to play with this for just a second because I do have a couple different systems that we use to do this. I mean, there are several systems. They use similar commands, but they're not all exactly the same. So I'm gonna play with that for just a minute. So you'll notice what I'm doing here inside the script, though, is I'm making sure that I'm going into the Scratch directory, and then I'm starting up my job. And I think that's a wise choice. I'm also using Singularity instead of Aptainer, and I have these couple of flags that I need to add. The first one is to add the GPU option so that we can run using the GPU, and then also I want to make sure that my home directory is set to be my Scratch directory rather than the typical directory that I usually use, the regular home. So if you don't have this setting here, then you'll end up using something other than Scratch, right? It'll use your home directory and you'll run out of space. So we make sure that we have this sort of information there. Now for submitting the job, right, if I want to make this happen, then the best thing that you'll want to do, let me look through my history here and look through some of these srun commands that I've run. So if I want to request different kinds of GPUs, I have to provide different flags. So I'm going to submit a batch job this time. I'm going to select to run that on one of the T4s and a GPU. I do have to be careful about what exactly I'm running and how much memory I'm using. So I'm going to try to edit this a little bit to make it appropriate for running one of our jobs. So, okay, first thing, like I said, memory, probably 32 gigs. It would probably make sense. We could adjust the number of cores if we'd like. Honestly, you're probably okay if you just leave it at number of tasks 1. You're probably submitting a job. Here we're saying we want to request one of our T4 GPUs. We could swap that for the A30, A100, etc. Partition, we have to set to be GPU because we have more than one partition on this system. So I'm using the GPU partition. The job does need to complete in a reasonable amount of time, so I'm going to say, well, it's not going to take long, right? So I'm going to say maybe just 30 minutes for this job. 32 gigs of RAM is usually a pretty good buffer. Most jobs will be just fine with 32 gigs of CPU RAM. That doesn't connect it to the GPU RAM in any way. The T4 just is set to 16 by default. So that's one task that we're trying to run on this job, and then I just put my script. So I've submitted that now, and it'll say, yeah, I'm going to be charged, and this is what we're charging it to. You don't have to worry about that because you'll probably just be added to the one allocation that you're responsible for. I'm going to take the, let's see, let me just take a look at the info here again, right? Just see what I have. So you can see the jobs. I'm just looking for my jobs instead of everybody's, and you can see the jobs already running. So it has, I think it already did select 4 cores by default for it to go with a T4. So that's just also agrees with what we had set up on the other system with 32 gigs. Things are running. Of course, that's job 555.222. So I can get the output of that in 555.222.out. Oh, I hit my same error that I usually had before, right? So as a result, I can check back in the queue and you'll see the job's already done, but that's really because it ended in an error. So I'm going to clean out my log directory so that I can make sure that that doesn't happen again, right? So remove that log directory. All right, resubmit my job. And then at that point, you don't get charged the full amount unless it runs the full amount, and you can still, we have should have plenty of credits here to be able to make this work. I'm going to look at this. All right, so we are running, and this time it's again, sorry, that's the wrong job. It's 555.224. So I'm gonna look at the output, 5224, for this one, right? And so we can see that the job has started up, and we can check on it from time to time. So now we're processing on epoch 0. I'm going to go back over to this interactive sessions here and close this down because I'm not using it currently, right? This is not, I was just using to illustrate that I had a job in the queue. So let me go back and take a look at my jobs now. I'm just down to the one job that's running that I just submitted as a batch job. Has up to 30 minutes, but we're already on to epoch 2. There are 50 epochs, so this will easily be done within the 30-minute time frame. And we'll be able to collect those results, and we could use the interactive session if we wanted to do that, find that information. Just remember that you are running out of scratch, right? So that's the important thing to keep in mind whenever you're running your scripts. So I'll just show that one more time, right? So when making the script, always CD into scratch. Use Singularity exec with an NVIDIA option. Make sure your home directory is mounted as scratch, and then you'll use MyStack, which is the same link here. That'll be, and then you run Python, your Python script through that container, and you'll be able to finish that up. So similar jobs can be set up for all the other GPUs that are available on Faster, but this provides a nice interface. Just as an aside, you guys will not have this, but if you are also on ACES, ACES works in exactly the same manner. So the nice thing is that they're basically the same type of system. They have the same on-demand portal. You'll log in through Access, just like we do through the others. Of course, I've already been logged in via Access on the other system, so it should just see that and let me through. Yeah, it is taking a moment right now, but the login system does back up a bit, I think, when on these systems from time to time. We're getting there. I may need to redo this, but hopefully this is kicking over. I'm being impatient. Sometimes it does take a minute for the ACES portal to load. Same thing with TAMU Faster. So if you do have to wait on that screen for a moment, I do recommend trying to be patient. It might very well be that it's working just fine. But every now and then things get held up, and it just gets sort of caught up in the login process. So we're going to probably take another run at this, see if it works. Oh. Yeah, I'm going to take another run at this. So portal, so this is for ACES. Okay, now it's telling me to log in again. I'm going to hit the code. Alright, there it went. So it's finally responded this time. Now it's logging me in. Now I do my little two-factor thing. Alright. I'll get logged in. And hopefully that'll get me into the portal for ACES. Yes. So if you do have access to ACES, it works similarly. You can go to your interactive sessions. You can run Jupyter Notebook. You can specify the same place. I'll stick everything in the same place. So use containers, Singularity, Charlie Cloud. I have this in a different spot, but I'll move it to the same spot as the others. You can select here, of course, H100s. I've tried using the A30s. They don't work on here, so they only work on Faster. I don't know what. I don't know whether maybe they don't have these installed yet. But the H100s are 80 gig cards. Just make sure you kind of set an appropriate number of cores in memory. Those are bigger jobs, bigger GPUs, so I have more cores and more memory. But it'll run through the same system. It has the same access to the shell. And just while I'm thinking about it, I'm going to go over and make sure I move this image where it needs to be. And move this thing here and provide the necessary link. Alright, so that way they're in the same location across all the systems. Let's see what I did. Try that again. That's what I meant to do. Here we go. Alright, so there we have everything linked up and ready to go. So the same thing will work on ACES. Of course, in the course, you will not have access to ACES. You'll just have access to FASTER. But you've got plenty of great GPUs to work with over there, and it seems to be generally more available than ACES most of the time. Most jobs have to sit in the queue for a while in ACES, but they do have the larger memory jobs, more for research than for classwork. So, all right. We'll see you guys in class.